Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This channel with videos with practice problems for actuarial exams is at smarturl.it/pass actuarial exams. Here you find information about online seminars for exams P, FM, IFM, and LTAM that I teach. That's at smarturl.it/btdt-online. And I also authored study manuals for exams P, FM, IFM, and LTAM. You can purchase those at the websites that I gave you here. So smarturl.it/btdt-p, and so on. BTDT stands for been there, done that. That's what you should be able to say while you're taking the exam every time you look at a problem on the exam. You should be so familiar with the material that you immediately know what to do. If you're not prepared like that, you're not prepared for an actuarial exams. You have to be prepared like that. That's why you need to do thousands of practice problems, and you need to study for hundreds of hours. That's how you need to study. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. This is problem number 6, the last one on the last exam LTAM, which was, by the way, of course, the first exam LTAM ever offered. The new exam started in July, and it was offered in October 2018. This is the written answer section, the last problem in it. ABC Corporation offers its employees a final salary defined benefit pension with an accrual rate of 2% per year of service. The final pensionable salary is the salary earned in the final year of employment. The pension is paid as a single life annuity due with a 10-year guarantee. Employees contribute 6% of pay at the end of each month throughout their period of employment. Riley is an employee of ABC who is about to retire at age 65. She was hired at age 30 and has worked continuously since then. Her starting salary was $40,000 per year. You are given the following additional information. Salaries increase monthly at the rate of 3.6% per year compounded monthly. The two-term Woolhouse formula is used for valuing the retirement pension. Mortality is assumed to follow the standard ultimate life table. The valuation interest rate is 5%. Note that this is the interest rate used for actuarial present values in the standard ultimate life table. Members have the option of taking a lump sum at retirement equal to the expected present value of their retirement pension using the valuation assumptions. Part A. Show that Riley's monthly pension is $8,050 to the nearest 10. You should calculate the value to the nearest 0.1. Part B. Calculate the expected present value of Riley's retirement pension at age 65. Part C. Show that the accumulated value of Riley's contributions at retirement, assuming interest of 9.6% per year compounded monthly, is $995,500 to the nearest 100. You should calculate the value to the nearest 10. Part D. Assume that Riley takes up the lump sum option. State with reasons whether the internal rate of return IRR that Riley has earned on her contributions is more than or less than 9.6% per year compounded monthly. Employees have the option to take a higher monthly pension at retirement without a guarantee period. The revised benefit has the same expected present value at age 65 as the standard benefit. Calculate the revised monthly payment. Part F. Part 1 of F. Define adverse selection. Part 2. Explain how adverse selection might impact the pension plan's cost based on the employee's selection of annuity with guarantee, annuity without guarantee, and lump sum. And here's the solution. So salaries increase monthly at the rate of 3.6% per year compounded monthly, so they effectively increase at 3.6% divided by 12, which is 0.3% per month, and every month previous month's salary is multiplied by the factor of 1.003 to obtain the current month salary. Riley's starting salary was $40,000 per year, or 40,000 divided by 12 in the first month, and then multiplied by 1.003 every month. Therefore, the final pensionable salary is 40,000 divided by 12 times 1.003 to the power of 12 times 64 minus 30, because the last year of work she's 64, and 12 because the accumulation is every month, times plus 1.003 to the power of 12 times 64 minus 30 plus 112, that's an extra month, and so on up to 1.003 to the power of 12 times 64 minus 30 plus 11 over 12, the last month of work. Well, we restructure it by factoring out 1.003 to the power 12 times 64 minus 30, and we are left inside with 1 plus 1.003 plus and so on up to 1.003 to the 11th. That's a partial sum of a geometric series, so that's equal to 1.003 to the 12 minus 1 over 1.003 minus 1. And now we can calculate this, and it comes out to be about 138,044.4702. The monthly pension benefit is 0.02 for every year worked, 2% of salary. That is the pensionable salary we just calculated, so 2% of that, times 65 minus 30. That's the number of years worked, times 112 because it's monthly, not annual, so we divide it by 12 to get the monthly amount. And that's approximately 8,052.59. The expected present value of Riley's retirement pension at age 65 is approximately 12 times that monthly benefit we just calculated, 8,052.59, times annuity certain over 10 years but monthly, paid monthly, plus deferred by 10 years life annuity starting at age 75, so 10 years after the period certain. And then we use the standard ultimate life table to get the pure endowment factor. We can calculate the annuity certain. The A.75 up 12 is calculated from the value of A.75 and from Woolhouse formula that says that we adjust it by subtracting 11 over 24. And once we do all that, that's really m minus 1 over 2m, by the way. And m is 12. That's why it's 11 over 24. So this comes out to be altogether about 1,293,125.30. For Part C, at the end of the first month of work, 6% of the first month's salary of 40,000 divided by 12 is deposited into an account that earns interest at the monthly rate of 9.6% divided by 12, which is 0.8%. The accumulated value at age 65 is 0.06 times 40,000 divided by 12 times 1.008 to the power of 12 times 65 minus 30 minus 1, because it's at the end of the first month of work that the deposit is made. At the end of a second month of work, 6% of the second month's salary, which is 1.003 times 40,000 divided by 12, is deposited into an account that earns interest at a monthly rate of 9.6% divided by 12, which is 0.8%. So the accumulated value at age 65 is 0.06 times 40,000 divided by 12 times 1.003 times 1.008 to the power of 12 times 65 minus 30 minus 2. And we continue like that, etc. At exact age 65, the end of the 35th year of work, or 420th month of work, 6% of the monthly salary at age 64 plus 11 over 12 is deposited into the said account. The salary in that last month of work is 40,000 divided by 12 times 1.003 to the power of 12 times 64 minus 30 plus 11. and the amount deposited, that amount, by the way, has no time to earn interest, is 0.06 times 40,000 divided by 12 times 1.003 to the power of 12 times 64 minus 30 plus 11 times 1.008 to the 0, because there is no time to earn interest. The accumulated value of all those deposits is a partial sum of a geometric series, and it equals, well, 0.06 times 40,000 divided by 12. And then inside, the rest is a sum of the terms that I just laid out, but we can then use the formula for a partial sum of a geometric series, which well, generally it's like this. It's 1 plus q squared plus and so on plus q to the n minus 1 is equal to 1 minus q to the nth over 1 minus q. And here, every time the amount is accumulated over 1 month less, that's why it's 1.008 to the negative 1, but it increases, the deposit increases by the factor of 1.003. So the ratio, the quotient of the series is this number, 1.008 to the negative 1 times 1.003. By the way, what I said about 1 plus q and so on, well, this is reversed. This is q to the n, well, actually, it doesn't matter. Sorry, you could just say 1 plus q squared and so on to the q to the n minus 1. That is equal to q to the n minus 1 over q minus 1. That's actually what we're doing here. And we actually don't start with 1. We start with the first term, that is the term subtracted at the top. But if you factor that out in front, you would have exactly the formula that I'm naming. So anyway, this is approximately equal to 995,523.95 as desired. So we note that the lump sum that we calculated in B is greater than the accumulated value of these contributions. By taking the lump sum, she would receive more than the value accumulated at the rate of return of 9.6% per annum compounded monthly, so her internal rate of return would be higher than 9.6% per annum compounded monthly. The revised monthly payment, and that 9.6%, I just realized I should have clearly said it's a nominal rate, not effective rate. That's why compounded monthly. The revised monthly payment offered without a guarantee period is calculated as the value of the benefits divided by 12, a double dot 65 upper 12, instead of the annuity composed of the period certain and the deferred annuity, and using Woolhouse and using a standard ultimate life table. We write this as 1293,125.30 divided by 12 times 13.5498 minus 11 over 24, and that comes out to be approximately 8,231.55. This compares to 8,052.59 calculated before, when the pension included a guarantee period. Adverse selection, in general, is defined as the situation when two parties to a transaction have unequal amounts of information, and the party with more information uses that position to trade to their own advantage at the cost of the party, I should have said here, so my apologies, I corrected the typo, with less information. In insurance, it is generally assumed that the insureds have more information about their own private circumstances and use that advantage to insure themselves against risk that they know they are prone to, and to reduce coverage for insurance they purchase when the insureds are not prone to risks covered. In the case of this policy, the insureds with impaired health are far less interested in payments far in the future because they are less likely to receive them. Thus, the unhealthy insureds will choose the lump sum option. On the other hand, healthy insureds will want to collect the lifetime benefits. The insurer may make some assumptions of the composition of the population insured in terms of healthy lives and lives with impaired health, but the customers are given options for how they receive benefits and will choose an option that is most beneficial to them based on private information available to them. So if you have a grandma that lived to be at least 100, like me, then, well, you're interested in long-term payouts. Please remember, this is copyrighted material. The problem belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.